Alright, this video is about functions and how you can add and multiply and divide and create a composition of functions. It's from Chapter 7, Section 6 in your book. So let's talk about some notation first. So f plus g of x, what that really means is you have some input x that you put into the function f and you get some value out. And you take that same input and you put it into g and you get some value out, and then you're going to add those two things together when you're done. The same thing is true of f times g of x. Notice this is a closed circle. That means multiplication. I make a point of that because in a second we're going to see something that looks similar to this but it's different. And what this means is you take some value, you plug it into f and you plug it into g, and whatever you get out from each of those you multiply the values together. Same thing is true with subtraction and division, except with division it's really important that whatever value you plug into g cannot spit out 0, because then you'd be dividing by 0 and you have some serious algebra problems. Okay, so let's do this with an example because I think it makes it a little bit easier. So f plus g, what it wants us to do is add these two functions together. So what this means is I take some value x and I plug it into f, and I'm going to get out an f of x value. Okay, so I'm going to get out an f of x value. I take some value x and I plug it into g, and I'm going to get out a value, and I'll add those two things together. So let's go ahead and do that with a couple of numbers. So let's say x is 2. Okay, so if I plug 2 in to f, what f does is it takes 2 and it multiplies it by 3, and then it adds 8 to it, which is 14. So I get 14 for f of 2. With g, if I plug 2 into g, what g does is it takes your input, multiplies it by 2, and then subtracts 12. So here I would get negative 8. So then when I add negative 8 to 14, I get 6. So f plus g of 2, so if I wrote this with the correct notation, I would write it as f plus g of 2 is equal to 14 plus negative 8. Well, we can figure out what that rule is in general. If I want to know what f plus g of x is, then I take 3x plus 8, because that's, if I plug x into f, that's what it spits out. It spits out 3 times x plus 8. And if I plug x into g, it spits out 2x minus 12. That's what g would give me. And now I can simplify these by combining like terms, and I get 5x minus 4. So my general rule for f plus g of x is 5x minus 4. Well, let's try it with f plus g of 2. f plus g of 2 would be I plug in 2 and I get 10 minus 4, which is equal to 6. So it's the same value that we saw earlier. So f plus g is 5x minus 4. Let's do f minus g. f minus g is the same thing that you might think. You take x and you plug it into f and you get 3x plus 8, and then you subtract what you would get from g. So you take x, plug it into g, and you would get 2x minus 12. And so this is the same thing as 3x plus 8 minus 2x plus 12. Make sure you distribute the negative to both terms, which is equal to 5x, whoops, not 5x, 1x plus 20. So f minus g is x plus 20. Okay, same thing is true with multiplication. You can multiply two functions together. Let's say I plugged in 2 again for f. Well, what f would spit out is 2 squared minus 1. So now what f does is it takes the input, it squares it, and then it multiplies it by 1. So that's subtracts 1. So I would get 3 for 2. If I plugged in g of 2, what g does is it just adds 1 to it. So now I have 3. So my output for both of them was 3. So f times g should be 3 times 3, which is equal to 9. Let's do the general version and see if that's what we get. F times g is the same thing as f. When you plug in x, you would get x squared minus 1 is what would be spit out. And g, if you plug in x, you would get x plus 1. Now we're going to multiply these two things together. X squared times x is x cubed. Negative 1 times x is negative x. Negative 1 times 1 is negative 1. And x squared times 1 is x squared. So here's my general rule. I'm going to write it in standard form. We have a polynomial in standard form for f times g. Well, let's see if f times g of 3 gives me 9. That's what we got earlier. So 3 cubed plus 3 squared minus 3 minus 1. That's 27 plus 9 minus 3 minus 1. Uh-oh. I've got some kind of mistake here. Hate it when that happens. Oh, right. It was f times g of 2, not f times g of 3. Just kidding. F times g of 2 is 2 cubed plus 2 squared minus 2 minus 1, which is 8, plus 4 minus 2 minus 1, which is in fact 9. That's 12 minus 3, which is 9. Okay, so it did work out. Whew. So this boxed in answer here is the polynomial for f times g of x. Okay, let's do f divided by g of x. That would be x squared minus 1 over x plus 1. And x squared minus 1 is the same thing as x minus 1 times x plus 1, because it's a difference of perfect squares, all over x plus 1. These two things are going to cancel out, and f divided by g is equal to x minus 1. But remember, we have that caveat that g of x cannot equal 0, because then we'd be dividing by 0. Well, g of x is x plus 1, so x plus 1 cannot equal 0, which means x cannot equal negative 1. So this x minus 1, we have a kind of a f of g of x is equal to x minus 1 so long as x is not equal to negative 1. Then this is true. Alright, now we have something, this is what I was referring to earlier, fog. This is an open circle, and it stands for the composition of functions. What a composition of functions is it's saying you have two functions here. You have a function g, and you have a function f. You're going to take some input like x, and you're going to put it into g. And g is going to spit something out, g of x. Okay, that stands for the output. And then what you're going to do is you're going to take the output of that function, and you're going to plug it into the other function. And so what comes out is f of g of x. That's how you would say that, f of g of x. That's the composition function. You take the output of one function and you plug it in as the input of another function. Let's do this with a couple of values using f and g as we have them defined here. So what f does is it's a function that subtracts 2 from whatever you put into it. And what g is it's a function that whatever you put into it, it squares. So let's put 2 into g. G squares things, so 4 comes out. Now we're going to take 4 and we're going to put it into f. And what does f do? It subtracts 2 from whatever you put in. So what comes out of f is 2. So when you plug 2 into g, out comes 4. You plug 4 into f, and out comes 2. Let's do another one. You plug 3 into g, and out comes 9. You plug 9 into f, and out comes 7. So when you plug in 3, you get 7. What about when you plug in x? When you plug in x to g, what comes out? X squared. Well, let's plug that in to f, and what comes out of f? X squared minus 2. You subtract 2 from whatever you put in. Alright, so let's look at this without our little boxes here. The composition function f of g of x is f of g of x, like this. Well, g of x is equal to x squared, so this is the same thing as f of x squared. And what this means is you plug in x squared. What we have here is a rule that's saying whatever you plug in, you subtract 2. So if we're plugging in x squared, we have to subtract 2 from x squared. This might be a little bit easier if I used a different variable. Let's say f of g of a. Alright, well if you plug a into g, you get out a squared. Now f, let's plug a squared into f. So if we plugged in a squared here, that would be the same as a squared there, and we would get a squared minus 2 out. So f of g of a, or f of g of a, is equal to a squared minus 2. That would be our rule. Let's test our rule and see if it works. 2 squared minus 2 is equal to 2, so this is f of g of 2, and that's what we found. F of g of 3 was, let's see what it was. F of g of 3 should be equal to 3 squared minus 2, which is 9 minus 2, which is 7, and that's what it was. So we see that our rule is spitting out the correct values. Alright, let's do another example. Let's do f of g of negative 5. Well, when you just have a number -5, this is the same thing as f of g of -5. You can just plug in -5 and evaluate it. So let's do that. -5, so this is g of -5 is equal to -5 squared. You take the input and you square it, which is 25. So now I'm going to replace g of -5 with 25. So I replaced this term here, g of -5 with 25. F of 25, what does f do? It takes your value and it subtracts 2. So f of 25 is equal to 25 minus 2, which is 23. That's what we get. Let's check our composition function that we found earlier. We said f of g of x is equal to x squared minus 2. So if we're plugging in -5, we should get -5 squared minus 2, which is 25 minus 2, which is 23. And that's what we did, in fact, get. Let's do another one. G of f of -5. So this is slightly different. This is saying we're going to take -5, we're going to plug it into f first, and then we'll take the output from that and plug it into g and see what we get. So let's start, let me write -5 here. G of f of -5. So let's start with the inside. F of -5. What does that equal to? Well, you take -5 in for x, and what f does is it subtracts 2 from whatever you put in, so you get -7. That's going to be our input over here now. So we're going to say, what's g of -7? Because again, f of -5 is right there. So I'm just substituting -7 for f of -5. G of -7, what g does is it takes its input and it squares it, and that gives us 49. So f of g of -5 gave us one value that was totally different than g of f of -5. So these two things are not the same. And in fact, let's find g of f of x. What is g of f? Or actually, I'll use a. What's g of f of a? Well, that's g of f of a. What's f of a? Well, if you plug in a to f, what it does is it takes that value and it subtracts 2. So f of a is a minus 2. F of a is a minus 2. Now, we're going to plug a minus 2 into g. So g of a minus 2 is equal to your input squared. G takes things in and it squares it. So g of a minus 2 is equal to a minus 2 squared, which is a squared minus 4a plus 4. So this is our rule for g of f of a squared minus 4a plus 4. And let's see if that gives us the same value for -5. Let's plug in -5 here. That's 25 plus 20 plus 4, which is going to be 49, which is what we had before, which is great. That's what we were hoping for. So that's how you manipulate functions. You can add two functions together. You can divide two functions. You can multiply two functions. You can subtract two functions. You can take the output of one function and use it as the input for another function. So what a function is it takes a value and it spits out one other value. That's what makes it a function. And so because it always spits out a value that's unique, you can add those values together. You can create new functions from functions, and you can compose functions. You can create a composition of functions. And that's it for this lesson.